Question 6. So this is model of the atom. Over 100 years ago, scientists thought that the atom was like a plum pudding. So plum pudding was J.J. Thomson. The diagram shows the plum pudding model. So we've got that labelled for us. The scientists knew that the atom had a negatively charged particles. They also knew that the atom had no overall charge. What did the scientists conclude about the charge of the pudding part of the atom? Well, if it's got negative parts in here, then in order to be overall neutral, then they thought that the pudding was just a general positive charge. So they thought that the pudding part was a positive charge, which was equal to the negative. So the positive charge equal to the negative charge. Two scientists named Rutherford and Marsden devised an experiment to investigate the plum pudding model of the atom. The experiment involved firing alpha particles. Remember, our alpha particles is 2 protons and 2 neutrons, or a helium nucleus. So mass of 4, total number of 2. The scientists measured how many of the alpha particles were scattered. The plum pudding model, the scientists predicted that only a few of the alpha particles would be scattered by more than 4 degrees. So if the plum pudding model was right, that's what would have happened. Yeah, this would have a positive charge as well, because we've got 2 positives and no charge in the 2 neutrons. So let's have a look. Over several months, more than 100,000 measurements were made. The results from this experiment caused the plum pudding model to be replaced by a new model. I'll explain why. Right. Well, the general thing if you replace a model is that the new data did not support the old model. It's just a general statement that if ever you're replacing a model, the new data did not support the old model, and the old model was the plum pudding. Okay, let's get into the explanation why. So why did it not support it? This is because it said that the old model, say here, they expected only a few to be scattered more than 4 degrees. But what actually happened in the plum pudding model was this: most of them, the alpha scattering, most of them did go straight through, which proves that our atom is empty space. But some of them were deflected by large degrees, more than 4 degrees, and some of them actually bounced straight back, which showed that there was something very small and very dense in the middle of the atom. So how does this explain why it needed to be replaced? Well, it explains it because a significant number of particles were by more than the expected 4 degrees. Some of the alpha particles were deflected straight backwards, so straight back, which wasn't predicted for at all, which could not be there's nothing in the Plum Pony model that's dense and small, so that couldn't explain that. And yeah, I think that'll be fine. I've explained it's only worth 2 marks. So just read our answer again. So new data did not support the old model, as a different number of the particles reflected more than 4 degrees, and some of the other particles reflected straight back, which could not be explained by the Plum pudding. Yep, 2 marks, absolutely fine. Suggest one reason why other scientists thought this experiment provided valid evidence for the new model of the atom. It's only worth a mark. The key is probably here. They did more than 1,000 measurements. You know, in science we always say, "Oh, repeat your results 3 times so it can be reliable." They've done 100,000, so it's pretty reliable. So they took 100,000 measurements. Right, so that's a lot. You could also say that the scientists were respected scientists within the community, or they did it over a long period of time. Okay, another 6 mark. That's 3 so far on this paper. In this question, again, good English. Describe the model used for the structure of the atom. Oh, sorry, describe the model now used for the structure of the atom. So the model that we use now is this one. So we've got protons and neutrons in the center. We call this the nucleus. Proton, that's the positive one. Then we've got neutron there, and then our electrons orbit in shells, or if we're being strict physicists, we'd say at different energy levels around the nucleus. There's our electrons. So that is our current model. And it's worth 6 marks. It says do not include a diagram, but we've done it up here anyway. That's not for this. This is to help us to explain it. So let's have a look. So let's see what we can do. So we could say give details of the individual particles. So as long as we mention these 3 particles, include the relative masses and relative charge of these particles. All right, so we can. There's another bit of. Oh, I jumped to the wrong question. There's another thing that we should have learnt when we did our revision. Is this table of proton. I'll make it a bit bigger so we can see it. So we should know about the protons, the neutron, and the electron. And we should know the mass and the charge. And we should know that a proton has a mass of 1, or a relative mass of 1, a neutron has a relative mass of 1, and an electron is almost 0. And the charge of a proton is +1, the charge of a neutron is 0, it's neutral, and the charge of an electron is -1. So as long as we get these 2 sections here into our answer, we'll be okay. We're just going to write it in words basically for 6 marks. So let's start with the structure. What should we start with first? We should say I'm writing in green. We say the current model of the atom contains 3 subatomic particles. And we're going to name them the proton is positively charged and has a relative mass of 1. this is located in the nucleus. Okay, so we mentioned the proton, we mentioned the mass, we mentioned the charge, and we've said that it's in the nucleus, so we've done that one. The neutron is neutral. It has a relative mass of 1 and is located in the nucleus. The nucleus has a positive, we should write it, and that's because it contains, just the protons and the neutrons. Neutrons are neutral, so the protons are positive, so they can only be positive. The third particle is the electron. This has a relative mass of almost 0 and a charge of -1. They, there's a lot more than one, they are located on energy levels. We call it, in chemistry we call them shells, orbiting the nucleus. Okay, let's see if our answer covers everything. Current mode of the atom contains 3 superpointed particles. The proton is positively charged, has a mass of 1, is located in the nucleus. So we've talked about the mass, we've talked about the charge, and we've talked about the structure, as in where things are located. The neutron is located, the neutron is neutral, so we've said that. It is located in the nucleus. Yep, so we've got that part of it. The nucleus is a positive charge. The third particle is the electron. This has a relative mass of almost 0 and a charge of -1. They are located in energy levels or shells orbiting the nucleus. Yeah, I think I've talked about all the different particles. I've talked about the masses, and I've talked about the charges, and I've talked about the structure. So yeah, I've done everything I need in order to get all of the marks, and that is the end of that question.